In what follows, we're gonna look at some applications of excision. The first important application is for computing homology of quotient. The following theorem allows us to relate the relative homology of a pair with the absolute homology of a quotient if we pass through reduced homology. And that is a benefit of using reduced homology. Using reduced homology, we will actually get a long exact sequence for computing homology of quotients. This long exact sequence is obtained from the long exact sequence for relative homology by applying this theorem. Alright, so let's see what the theorem said. It says that if we have a CW pair, X and A, then the homology of the pair X relative to A is going to be equal to the homology of the quotient X over A relative to a point. It's going to be equal to the homology of the quotient X over A relative to a point, which is just by definition the reduced homology of X over A. Note that here we use this notation because we are not specifying any homology theory. The only thing we're gonna use is the Excision Axiom, which is true for all homology theories. So let us first review the Excision Axiom. There are two equivalent formulations. Well, this one sounds a bit more like excision. If this whole space is X and this is A, and furthermore we have a subspace Z of A such that the closure of Z lies in the interior of A, then the excision axiom asks that the relative homology of X, relative to A, is going to be equal to the relative homology of X minus Z, so this part, B here, relative to A minus Z, so this intersection here. And that shows you this equivalent formulation. The relative homology of B relative to B intersect with A should be isomorphic to the relative homology of B union with A, comma A. So that was the excision axiom. Now let's try to use that to prove our theorem about homology of quotient. Let's start with a CW pair X and A. Our idea is to use excision on this space, which is obtained by gluing X with the cone over A along A. Now, what is the cone over A? That is the space we could obtain by gluing the cylinder over A here with a point along this map that squished this whole top, this whole copy of A to the point. When this circle is squished to a point, the cylinder becomes a cone called the cone over A. Now coming back, we want to apply excision to the space obtained from gluing the cone over A to X along A. By excision, we have the following isomorphism. But now observe that this X intersect with the cone over A, that's just A, because they are glued together along A. On the other hand, observe that when we attach this X to the cone over A, then now the homotopy type of the cone over A inside this whole space is just trivial. So here we have this is homotopic to a point. And when we squish this cone to a point here, then in particular we are squishing this A to a point. So we get that the homotopy type of this is just X over A. And look, that was just exactly what we wanted to prove. Thus now we have a method of computing homology of quotients, which we will use quite frequently.